we can define another random variable that is called the geometric random variable. And this is also a discrete random variable. And we suppose that the independent trials, each having a success probability P, are performed. Okay. And when we are going to stop performing these experiments until we observe our first success. So for a Bernoulli experiment, we are going to repeat the experiment, and each time the success probability will be P. We are going to repeat the experiment until we observe our first success. The number of trials that we perform until observing our first success is going to be a geometric random variable. And how many times can we repeat this experiment until we observe a success? So it should at least be one, right? So if you want to observe a success, at least you should try it for once. And theoretically, you can repeat the experiment infinitely many times, but still you may not observe any success. Of course, the probability of this would be very small if the success probability is large. However, if the success probability is also so small, in that case, you are going to repeat this experiment many times until you observe your first success, most probably. Now, how can we model the probability of a geometric random variable to be equal to x, which means what is the probability of you observing your first success in the x trial? This means first you need to observe failures for x minus 1 trials, then you are going to see a success. And the potential values that the geometric random variable can take are only positive integers, and the only parameter that it has is the success probability. Expected value of a geometric random variable is 1 over p. There's also a logical explanation for it as well, but I'm not going to do that. You can still calculate the expected value of a geometric random variable by using the expected value formulation. And we need to do a few mathematical tricks in order to convert this summation into 1 over p. And the variance of the geometric random variable is equal to 1 minus p over p squared. Now, let's solve this question about the geometric random variable. The probability that a student pilot passes the written test for his private pilot's license at any try is 0.6 independently. Actually, such an independence assumption here is a very strong assumption. Actually, there is this learning effect. For example, when you take this course, the probability for you to pass it, let's just say, is 0.75. Now, if you repeat this course, if you fail this course the first time, and if you take it for the second time, the chance for you to pass it should be increasing because of the learning effect, because you have learned many things, you have experienced many things in your first trial, and this is also a good knowledge for you to pass the class, right? But here, we are assuming that there is not a learning effect, and at each trial of this written test, the chance for the pilot candidate to pass the test is 0.6. And the question here is this: find the probability that a person passes the test on the third try. Okay, so this means in the first 2 tries, the student pilot is not going to pass the test, and in the third trial, he or she is going to pass the test. So in order to answer this question, I will say that x as a random variable represents the number of times that the student pilot takes the exam until it passes, until he or she passes. And that is going to be a geometric random variable with success probability 0.6. And question is asking the probability of x being equal to 3, and that is equal to success probability times the failure probability to the power 2. Okay, and still we can calculate the expected value and the variance by using the regarding formulations for geometric random variable, just for the sake of completeness in this question. Actually, the question is not asking this at all.